And you do example 7 and 8. What do we get for example 7? Make sure we have units on there to be new. Everybody okay on that one? Example 8, if you set it up like this, and this is what we were just talking about, math 1 is 1200, math reserve is given. That's 24. If you set it up like this, your R is not answering the question. R is going to be the distance to the center of the Earth, which is going to be from here to there. And the question asks, how high above Earth's surface is it? Which means we want this distance here. So if we have this, we want this, we can subtract out that radius of the Earth, and that should give you your area. What do we get for the final answer? 1.8 at 10 to the 7th meters is correct. That is really far. 18 million meters. That's like really far under that. All right, moving on. Everybody back up here. Next thing we need to talk about are contact forces, including the normal force and the frictional force. What is the normal force again? We talked about it before. What's that? Counteracts gravity when not moving. Counteracts gravity, yeah, kind of. Basically, I'm standing here on the ground, gravity is pulling me down, and most of the time the normal force will counteract gravity. So if I'm not moving down, there's a contact force between me and the floor that's pushing me back up, right? Contact force between two solid objects is always perpendicular to the contact surfaces. So most of the time we think about normal force being straight up because most of the time we're on a flat surface and I'm standing here on the floor. Normal force is pushing me back up. But we will be doing plenty of incline problems, and in that case, the normal force will be perpendicular to the incline. It won't be straight up.
So then we spin on water, that force that's counteracting is not strong enough.
Right, the buoyant force is not stronger than gravity, so it goes to bring you down. All right, if the buoyant force is stronger than gravity, then it's in what case would the normal force be equal to the weight of the object? A lot of times people find the weight, mass times 9.8, and then they assume that the normal force is that. A lot of times that's true. What would an instance for that be? Something on water. When we're talking water, we're more talking buoyant force than we are normal force. We want two solid objects. What about me right now? If I am being put down at 170 pounds before it puts me back up on me at 170 pounds, all right? If we just have a boat sitting on the table, gravity's pulling it down, that's its weight, normal force is pushing it back up. Those are two equal things but opposite, right? What about when the normal force is greater than the weight of the object? How would that happen? If I have that same book sitting on the same table, how could we make the normal force greater than weight? No, because then weight, we're talking about acceleration due to gravity on the moon. Same book, same table, same location, same planet. Put a spring underneath it. If it were on an incline, I like the way we're thinking. If it's on an incline now, how's that going to change it? Is that going to increase it or decrease? Yeah, it's actually going to decrease it. Absolutely it can. If I have, suppose this is a boat, suppose it weighs 10 newtons. So we have 10 newtons going down. Right now we have 10 newtons going up, right? What if I push down at 2 newtons? Now, what downward forces do we have? Gravity at 10, me pushing down at 2, right? Normal force would be 12 newtons pushing back up, right? Because if the forces down are more than the forces back up, it's going to move down. Does that make sense? So if you're pushing down on an object, or anything pushing down on an object, the weight is going to be less than the normal force. How then could the normal force be less than the weight? You could pull it up, so maybe you have the spring to it, you're pulling up at 10 newtons, gravity's pulling down, gravity's pulling down at 10 newtons, I'm pulling up with 2 newtons. So I'm not going to be able to lift the book because I'm not pulling more than its weight, but that's going to decrease the normal force. Or as we talked about before, if it's on an incline. If it's on an incline, the normal force is only going to be a component of the weight. It's only going to be the X and Y component. We'll talk about that when we look at it. Questions about normal force? What's friction? We don't need to worry about what this room would look like without friction. Okay, talk about it. What would this room look like without friction? It would just move, yeah. So if I gave something a little bit of a force, it would just keep going. So it's the wall. Everything, not only would everything be bouncing around, everything would be shoved into one corner, whichever way the force kind of slightly slanted. Everything would just slide down into that corner and be jammed in the corner. Awesome. Not really. All right. So that's what the class reference would look like without friction. Why does friction occur? Hopefully we know what friction is. Contact force that opposes motion. Why does friction occur? Why does friction even exist? We just talked about how it's a good thing that friction exists. You wouldn't be able to walk without friction because as I'm taking a step forward, by pushing that way, so the force is pushing me back in the direction I want to go. Why does this even happen to begin with? Let's take a look at a much smaller view. All right, here we have a person sliding on a sled. If you look at a microscopic level, so you zoom in big time on the surface, I think that's actually a slide there. So we're looking at a zoomed in view between the feet of the pants and the slide. Even though that looks like it may be a smooth surface, all right, any surface is really, really rough, right? And then depending on the object, it might be more smooth or more rough. Well, those sharp curves, as they're brushing against each other, notice our normal force is going to change its direction because the incline and the surface has changed slightly, right? All right, so that's that contact force. Also notice, depending on the two surfaces, there may be a little bit of bonding going on between the molecules. If you zoom in even more, we have a little bit of bonding that's going on that's hanging on to before it releases into the test. All right. What about static friction versus kinetic friction? You guys talk about that. Look at this. Good. Static friction is a frictional force on an object that is not moving. Kinetic friction is a frictional force on an object that is moving. Kinetic friction resists the motion. Static friction will resist. So I'm trying to push it this way, and I can't. I'm not pushing hard enough. Gravity is pushing back against the other direction. If I get around on the other side of the podium, turns around. Which one of those is greater? Static friction or kinetic? static friction goes. It's always more difficult to start moving an object than it is to maintain its motion. Why might that be? Going back to what we talked about here on Microsoft stuff. Yeah, it's kind of pushed down a little more and kind of locked into each other. Once it starts moving, it's going to be going over the top of the surface. Right? All right, let's look at the math of it real quick. And then we might have to make a small adjustment for homework on the sheet there. Static friction is F sub S is less than or equal to U sub S times N. Kinetic friction is the same thing except for an equal sign. I think the formula on your equation sheet kind of combines those and simply says force due to friction, that's capital F, is less than or equal to U times N. Capital N is the normal force. What's mu? Coefficient of friction depends on what? The two objects, what they're made of, right? What kind of units does mu have? Unit list. There are no units on it. It's a coefficient. The bigger it is, the harder it is to move the object. All right. So ice would have a very small coefficient of friction. Between ice and something. Obviously bigger than why is it less than or equal to? Why less than or equal to physics? Yeah, we'll talk about that next time. Think about that. Double check the homework. Any problems that deal with gravitational force, I'm not sure there are a lot of them. That's the ones I want you to do. Any of them that deal with frictional force, you can skip for now. All right. I believe that the first few are gravity, the last few are friction. The quiz will be pushed back. It won't be next class. It will be involved. Yeah.